This is the explanation of 2.3 algebra and problem solving that we missed because of the snow day today. So I'm going to try and explain the notes to you. Let's clean side of it. Okay, so if you say, I'm doing example 1, you are paid 5 cents for each can that you're going to return, and it is 3 cents for each bottle. So what you are going to do is try and figure out how much money you can make. Well, of course, it also depends on how many cans and how many bottles. So let's say we have C cans. It's an unknown number. So we are going to receive 5C plus 3. What do they use? They use B for bottles. Okay, that would make sense. All right, so that's an example of that. Now, on the bottom of page 10 in your notes, the translating phrase into algebraic expressions, these are huge. You have to understand that the addition is going to be a plus. You can also say the sum of two numbers, 5 greater. Let me just go on to the next slide here. All right, so for addition, you could have the sum of 2 and 3. You could have 2 greater than 3. You could have 2 increased by 3. Now, 2 more than 3, actually that looks like this, because you have 3 and you're putting 2 more into it. So that is how you would do that. But of course addition is commutative, so I will accept any method. 2 exceeds, or is exceeded by 3, and then a total of 2 and 3. All right, so that's addition. For subtraction, this is a little bit trickier because subtraction is not commutative. So what we have is the difference of 5 and 2. That does not mean plus. It's the difference of 5 and 2. 5 comes first. 5 minus 2. That one's pretty clear. Less than. Now, if I wanted to say 5 less than 2, that would not be 5 minus 2. It would be 2 minus 5. I should have used a different number. Let's say 12. 5 less than 12. Think about your age. 2 less than your age. You're going to start with your age. So this one's backwards. And then we have another one that's backwards. Subtracted, decreased by, I haven't done that one. So 12 decreased by 5 would look like that. Subtracted from, all right, 5 subtracted from 12. So we're going to put the 12 first. And 12 reduced by 5. All right, so that is the first two. Then we have multiplication. Sorry, this is not very neat, but I'm trying to get this done for you. Product, the product of 2 and 3. Product means multiplication. 2 multiplied by 3. Twice 3. Times 2 times 3. Percent of, 20% of, 100. Okay, we'll talk more about percents another time. But I want you to realize that of means multiplication. So if you had said 1/2 of 5, 1/2 of 6, it would be 1/2 times. It's not division, it's multiplication. So if you see the word of, it means multiplication. All right, division. The quotient of 6 and 2. 6 divided by 2. The ratio of 6 and 2, 6 goes on top of this if it's mentioned first. And then per, you might say, let's see, 24 miles per gallon. Something like that. All right? So I'm going to do example 2. I'm going to read it. 3 less than m. Remember, that's the backwards one. So 3 less than m. That's what's going to look like that. B, y decreased by 10. Y decreased by 10. The product of 5 and x. The product, start with the dot if you want, 5 and x. You don't need the dot either. The quotient of n and 7. The quotient of n and 7, and goes on top. 6 times the sum of x and y. So we're going to 6 times the sum of x and 7, or a number in 7. The difference of 1/2 n and 12. The difference, so the difference of 1/2 n and 12. And you think of as 2 and 3 as addition, but you can have the product of 2 and 3, and that's multiplication. And this is the difference of 1/2 n and 12, but still subtraction. Now, in example 3, x minus 12, that could be written a whole bunch of different ways. X minus 12, 12 less than x, x less 12, lots of different options. So when you're doing your homework and you don't get what the book has, ask about it in class, because yours could be right. But there are some tricky things. All right, that's the second one. That's B. Oops. All right, so here we've got 7 times the sum of x and 12 would be an example, and I kind of like that one because it's 7 times the sum. If you said 7 times a number plus 12, that could look like this, 7 times a number plus 12. So there's some special wording that you need to use, or possibly a comma. All right, so that one was wrong. C, 5 plus. Now, I can't say 5 plus x over 2, because that could be 5 plus x over 2, which is wrong. So you'd have to say something like 5 plus the quotient of x and 2, or a number in 2. And D, let's see, D I'll put over here. We have 5 plus x over 2. So for this one, you might say the sum of 5 and a number, all divided by 2. And then I have one that's not in the book. I called it try. 3x squared. You can't say 3 times a number squared, because that could look like this, 3 times a number squared. And that's not what we want. So you had to say something like 3 times a number, comma, squared. Or the square of the product of 3 and a number. A lot of different things you could use. All right, this next section, example 4. And this is kind of huge. I'm going to go through it. We're going to be doing a lot of problems like this. If you have 1 dime, you have 10 cents. Actually, what I'm going to say is you have 1 times 10, which is 10 cents. If you had 2 dimes, you have 2 times 10, which is 20. I didn't mean to put the cents in there. See, I have a little eraser here. Okay, cool. All right, and then if I had 3 dimes, I would have 3 times 10, which is 30. Are you seeing the pattern? What if I had D dimes? Then I would have 1, 2, 3, 1, 2, 3, D times 10, and we would write that 10D. So that's kind of a huge example, and that was number, let's see, 4. 5 is just showing you, I should be putting down these examples. If you have 12 miles per hour and you're going to go a certain number of hours, so 12 miles per hour, and we're going to multiply that by a certain number of hours. Call it T hours. And you can divide by 1 if you'd like. Anyway, the point I'm trying to make is that the hours literally cancel. Your units cancel, and you're left with 12T. Miles. All right? Example 6. A person is paid X dollars plus 6% sales tax on the automobile. Write an expression for the total cost of the automobile. Well, the tax is 0.06 times whatever the item was. But we also have to pay for the item. So it's going to be X plus 0.06X. And we know the coefficient of X is 1, so we really have 1.06X. And your parentheses aren't necessary, but just trying to make a point. That's how you do it. All right. This is 7. A truck travels 100 miles at an average speed of r miles per hour. You need to know your formulas. I think I told you this is one you need to memorize. So distance is equal to rate times time. So if we want to solve for time, it's going to be distance divided by rate. So let's see. He's traveling 100 miles. That's our distance. at an average rate of r, we don't know, and we want to know how long it's going to take. Well, that's going to be t is equal to that. All right? Let's see what... I am not having you do example 8, a problem like example 8, because you may not have a scientific calculator, and you need a scientific calculator to do this. I can actually talk about this when I see you next time. But I do want to do example 9, because that's a good one. So we have a house here, and 2, 3, 4, 1, 2, 3, 5. 1, 2, 3, 4. Ooh. Pretty cool. All right. So anyway, we know that 2/5 of this house is used up by certain rooms, and we want to know what percent of the remaining rooms do we have. Not what percent, but what's the area. Well, we need to know that this is going to be a 40-foot house by a 25-foot house. So if I multiply 40, and you may use your calculator, but I always want to see the setup, you're going to end up with 1,000 square feet. All right? And we want to know what this remaining piece is right here. So we could do this two ways. I could say 2/5 of, remember that's multiplication, of 1,000, and I would end up with 400. And then I would take 1,000 and subtract 400, and I would get 600. And that is what's left. And it makes sense because it's more than the 400. Or I could simply say, well, if 2/5 is what we've already used, then there must be 3/5 left. So you could take 3/5 and multiply that by 1,000. And you would end up with 600, which is the same thing we got here. So we have 600 square feet. All right, this next example is not in your book, but you have a homework assignment, so I want to explain it. And this is really easy. Once you get this, it is very, very easy, but you will see this on quiz, exams, whatever. And you'll it's getting you ready for graphing. So for chapter 4, 5, and making a little box here with 20. All right, so they're giving you this information. 4, 9, 14, 19, 24, 29, and this one we do not know. So what is the change from 4 to 9 is 5. The change from 9 to 14 is 5. All these changes, oops, all these changes equal 5. And the changes is what your A is. This should be AN. I did not copy that right. Yes, that's an AN. So now we can say that A is equal to 5. Now B, let's do B in a different color. B is going to be the expression AN plus B. Well, if N is, let's say, 3 for example. So we have N we said was 5, and N we said was 3, plus B is going to equal 19. Well, this is 15 plus B equals 19, and therefore B, we haven't had solving yet, but I'll show you another way you can do this very easily. So B is going to be 4. All right? Now, a very simple way of doing it is let N equal 0, and anything here is going to equal 0, and so you're going to be left with B. So B is 4. So then the expression is going to be 5N plus 4. And if we want to solve for what is it going to be when N is 20, we do 5 times 20 plus 4 is 104. And that's what that's going to be. All right, so try these on your own, and we'll definitely go over them when I see you on Monday. Have a good weekend. Enjoy your day off.